this is Class 7 2025 books. I have covered 2024 Class 6 books in this channel. Please do check that out. Links will be in the description. Though I was not consistent with those videos, I promise I will be consistent this year, taking in detail every chapter of all the 4 books. So stay tuned. So if you have not subscribed this channel, so this is the right time. Please click the subscribe channel. Now let's see in detail all the 4 books, the main topics. So this is Max, and then comes the biology. It looks like this is their first multicolor edition. Yes, each chapter is extensively explained with multicolor images, beautiful pictures. Check out my channel for Class 7 Biology Chapter 1 in 2-part series, Part 1 and Part 2. I have also uploaded the MCQs covered in this chapter, a live reaction of my son taking the MCQs. All the links are in the description. Please do check that out. Now let's get straight to this video of Class 7 Max Chapter 1. Few pages consist of the highlights of the foundation series. In this, what this book comprises of is being shown here. Next comes the roadmap. In this roadmap, 6th, 7th, 8th, 9th, 10th, what are all the chapters that is being covered in this subject, and in which class the bases are covered and in which class the advanced concepts are covered. This gives a really comprehensive picture of the whole subject till class 10th is given, which is very useful. Next, the chapters covered are given here. It is in accordance with NCERT syllabus. Next, each chapter is explained first, and then questions in an MCQ format is asked. And then after each lesson, concept map is given. This is a map comprising or consolidating all the main concepts that is being discussed in that chapter. So it is a quick flashcard you can go through and remember and recollect the concepts. So let's see the foundation course Max 7 2025. The chapters covered in this book is 13 and it matches with the NCERT textbook. So first let's see the first chapter, integers. So as always, I will start with the concept map and then revert back the points with the explanation pages along with the illustrative example. Let's get into this chapter, integers. So in these 2 points, they have explained how to add 2 integers, and in this point, they have explained how to subtract. This we are going to see in detail, so we will move on. They have also tabulated the properties of integer. So first, for addition, they have explained the closure property, commutative property, and associative property. In closure property is a plus b is an integer. Remember, this is for addition. For each function, it differs. For addition, a plus b is an integer. Next, commutative property. That is, a plus b is equal to b plus a. Next, associative property, that is a plus b plus c is equal to a plus b plus c. This is associative property. To understand what do they mean by this a plus b is an integer, for that first we need to understand what is an integer. Okay, so I would like to explain a bit about Euler diagram. You would have heard about it. Euler diagram of numbers. Euler diagram of numbers. So what is this Euler diagram of numbers? So let's see. First is our natural numbers. Okay, natural numbers. What are natural numbers? These are the numbers we use for counting, which starts from 1, 2, 3 and then so on. Okay, these comes under category called as natural numbers. Okay, natural numbers. What are natural numbers? That we use for counting. It starts from 1. 1, 2, 3 till infinity. It is called as natural numbers. But when you add 0 to it, okay, it becomes whole number. 0, when you add 0 to it, it becomes whole number. So whole number means it starts with 0, 1, 2, 3 and then infinity. So natural number starts from 1 till infinity and whole number starts from 0 till infinity, and then comes our integers. Okay, so what are integers? Integers are the integers encompasses all the whole number along with their negative counterparts. So all the whole number, that means 0, 1, 2, 3, 4 till infinity, along with their counterparts, that is minus 1, minus 2, minus 3 till infinity. Okay? So this is called as integers. So whole numbers, that is natural number along with 0 and their negative counterpart, are called as integers. Okay, now what comes next? What comes next is when natural numbers plus 0, so whole numbers plus integers, that is their negative counterparts, comes the rational numbers. Along with the rational numbers, so what are rational numbers? Rational numbers are, these are real numbers that that can be expressed in fractions, where q is not equal to 0. Q cannot be the denominator cannot be 0. So if it can be expressed in fractions, if any number it can be expressed in fractions, it is called as rational numbers. Okay, so now this inclusive of, so you would have heard irrational numbers. So what are irrational numbers? Irrational numbers are those numbers, the real numbers, that cannot be expressed in fractions of two integers. That cannot be expressed in fractions of two integers, and their decimal point, that is after the decimal point. Okay, after the decimal points, the numbers will be number representations are non-terminating, and also non-repetitive. That means, for example, pi. You all know the pi value, right? 3.14. It goes on forever, non-repetitively. Okay, it's non-terminating. It goes on, right? And then it is not repetitive. So it is not like 2.22222. It's not repetitive. 3.141414. It's not repetitive. So it is irrational numbers. Those comes under irrational numbers. The best two examples are pi and square root of 2. So irrational numbers. So what happens? So what comes next? What comes next is inclusive of the whole thing is the next most broadest category called as real numbers. Okay, all these things come under real numbers. So real numbers inclusive of the irrational numbers, rational numbers, integers, whole numbers, natural numbers. So real numbers is the broadest category of numbers. So Euler diagram explains this whole relationship between all the numbers, that is natural number, whole number, integers, rational number, irrational number, and also the real numbers. So a plus b is an integer. So here what they mean is it can be the negative counterparts, the whole number and also the natural number. So it is an integers. Okay, and then so I just wanted to explain you the Euler diagram of numbers for you. To quickly understand what's a natural number, what's a whole number, what's an integer, what's a rational number, irrational number, and then real numbers. Moving on, let's see in detail the chapters. Integers. Integers is a collection of positive and negative numbers including 0. This I have explained in detail. Now, what is absolute value of integers? Absolute value of an integer is the distance of that point from 0 irrespective of its sign. Here, absolute value of minus 6 is 6. So, when they ask absolute value, so what you do is you write only the numerical value. Forget about the sign. Forget about the sign even if it is negative or positive. So, absolute value of minus 6 is equal to 6. Absolute value of 5 is 5. So, this is what they have written. Absolute value of an integer is always positive because we are irrespective of the sign. We write it will be in 0 or it will be in positive or 0. Okay, and then absolute value of x is denoted by the symbol. This is the symbol. What's the symbol of absolute value? Is like this. We write it like this. So, adding an integer. Addition of integers is divided into 2. Okay. 1 same sign. Next is if two numbers have different sign. Okay. So if it's a same sign, what do we do? If it's a same sign, we apply rule. These are the rules. Number 1, you add the integers, add the numerical value of those integers. If it's the same sign, we add the numerical values of this integers, and then you apply same sign. Okay, because it's the same sign, you apply the same sign. Okay, now let's see with an example. Same sign. Okay, example 5 plus 3. 5 plus 3. How do you write? 5, 6, 7, 8. So the answer is 8. So here it's the same sign. Here is 5 means plus 5 and 3 is plus. Okay, if it's minus 5 plus minus 3, what do you do? Because it is same sign, you're adding two same sign integers. We apply the first rule, that is add the numerical values. Forget about the sign, add the numerical values. So 5 plus 3 is 8. Apply the same sign. So here, what is the same sign? Minus. So you write minus. So minus 5 plus minus 3, the answer is minus 8. Why? Because it's the same sign. Here both the signs are positive. Here both the signs are negative. So this is how you add same sign integers. Okay. Now let's do different sign. Rules. Number 1. So if it is different signs, example 10 plus minus 2. They have asked us to add these two numbers, 10 plus minus 2. What do we do? See, this is positive and this is negative. So this comes under different sign. So the rule number 1 is, because different sign, we have to subtract. It's the rule. Okay, it's the rule. You have to subtract the numerical value, and then apply the sign of greater number. Okay, now let's solve this. It is two different signs. So what do we do? Rule number 1, subtract numerical value. 10 minus 2 is 10 minus 2 is 8. Now we have to apply. Then comes the second rule. Apply the sign of the greater number. So what is the sign of the greater number? Greater number 2 or 10 or 2? 10 is the greater number. So positive is the sign of the greater number. So the answer is 8. So 8. 10 plus minus 2, the answer is 8. Let's do another example. Minus 10 plus 2. The two integers they're asking us to add is minus 10 plus 2. So what do? The signs are different. So we have to subtract. So 10 minus 2 is 8. Then we have to apply the second rule. Apply the sign of the greater number. So which is the greater number? Minus 10. So we have to write minus 8. So this is how we add the integers. Here they have explained that rule number addition of integers. Rule number 1. To add two integers of same sign. Okay, here, same sign. To add two integers of same sign, we add their values ignoring their sign and put the common sign with the sum. Here I have explained in detail, much more clearly than whatever they have given here. Okay, it follows two rules. Add numerical value and then you apply the same sign because it's the same sign, so no problem. Now, to add a positive and a negative integer, that is different sign. Okay, one is positive, one is negative, or one is negative, one is positive. If it's a different sign, we find the difference between the numerical value ignoring the sign and put the sign of the integer with the greatest numerical value with the difference. So this is how we do it. So same sign you add, different sign you subtract, and then put the great sign of the greater number. Next, properties of integers. So there are 5 properties discussed here. 3 they have already said. Here 2 more properties are added. So first one is closure property. So what is closure property? If a and b are 2 integers, then a plus b is also an integer. This we have explained in detail. Here they have given with an example. So minus 10 plus minus 5 is equal to applying the previous addition explanation. So both the same numbers, so you add and then you put the same sign. So that is how they get minus 15. So minus 15 is also an integer. So if you add 2 integers, the result is also going to be an integer. That is called as closure property. So minus 13 plus 9 is equal to minus 4. So here the 2 different signs are is there. So what do is we subtract and we put the highest sign of the highest number. So that's how we got minus 4. So here for minus 5 plus 5. So minus 5 plus 5, 0 is the answer. So that is the closure property. Next is commutative property. So what's commutative property? If a and b are integers, then a plus b is equal to b plus a. This is possible only in addition of integers. Okay, a commutative property. So a plus b is equal to b plus a. So let's see with an example. 11 plus minus 6. 11 plus minus 6 is equal to 5. Okay, so a plus b. So they're asking us to solve this to find if it's true. So 11 plus minus 6. What's the answer? There is a difference simple. So we have to subtract. 11 minus 6 is the answer is 5, and then we put the highest sign of the highest number, which is plus. So that's how we got 11. And if we reverse it, minus 6. So here, if you do minus 6 plus 11 also, the answer is going to be 5. That's how it is commutative property. A plus b is equal to b plus a. Okay, they have explained with another example. Next, associative property. Associative property, if a, b and c are integers, then a plus b plus c is equal to a plus b plus c. So here they have explained with an example. Minus 6 plus 10 plus minus 4 is equal to, you solve this. When you solve this, we have to solve this bracket first. So by solving this bracket, we get 4 and then plus minus 4, which is equal to 0. And if you do this, a plus b plus c, that is 6 plus minus 6 plus 10
plus minus 4 also you get the same answer 0. So that's how they able to prove that a plus b plus c is equal to a plus b plus c, associative property. Next comes additive identity. If a is an integer, then a plus 0 is equal to 0 plus a. 0 has no value, so it's going to be the same number. So that's called as additive identity. So 0 is the additive identity of all integers. Next, additive inverse. If a is an integer, then a plus the inverse of that, additive minus a, is equal to 0. That is called as so minus a is the additive inverse of a and vice versa. So additive inverse of minus a is equal to a. Additive inverse of a is minus a. So this is so here they have explained with a number 4 plus minus 4 is equal to minus 4 plus 4 is equal to 0. So this is called as additive inverse. So these are the properties of addition of integers.
So moving on, subtraction of integers. To subtract one integer from other, convert the integer to be subtracted to its negative and then add them. I remember how I learned from my teacher. So she said for subtraction, okay, she said a much easier way to understand. To subtract integers, what you do is you have to, so there are two numbers, correct? So number 1 and then number 2. So there is a subtraction symbol. So that we need to subtract number 1 and number 2. So what my teacher said is to write the from number as number 1 and the second number as number 2. So let's see an example, that is the question is subtract 10 from 20. So this is the question. So how do we do? As I explained over here, number 1 should be, first number should be from number. So from 20. So here the first number is from 20. So 20 as first number. Then you put the minus symbol subtracting from the other number, which is 10. Okay. So 20 minus 10. So subtract and then put the highest sign of the highest number. So here the answer is 20 minus 10, which is 10. The highest number sign of the highest number is plus. So the answer is 10. So this is how you subtract integers. This is a little bit confusing. So this is much easier. So first you write the from number and then minus symbol and then the other number. So that's how you subtract. Next, properties of subtraction of integers. Closure property, the same closure property, commutative property and associative property. Let's see how does it differ from addition of integers. So for subtraction, closure property, if a and b are two integers, then a minus b is also an integer. So this I have already explained. So with an example, 12 minus 4 is equal to 8. 8 is an integer. Okay. So if minus 20 minus 4 will be minus 16, which is also an integer. Next, commutative property. If a and b are integers, then a minus b is not equal to b minus a. What does it mean? So a and b are integers. So here a is equal to 3 and b is equal to minus 5. Okay. So as per commutative property, a minus b is not equal to b minus a. So a minus b. If a is equal to 3, b is equal to minus 5. So a 3 minus b minus 5 is not equal to minus 5 minus 3. So solve this. 3 minus will become plus, which is not equal to minus 5 minus 3. Minus 5 minus 3, which is not equal to 5, 6, 7, 8.
8 and the same sign minus. So 5, 6, 7, 8. So 8 is not equal to minus 8. So that is what they explained over here. Commutative property A minus B is not equal to B minus A because we are subtracting. Okay. Next, associative property. Associative property. If A, B and C are integers, then A minus B minus C is not equal to A minus B minus C. So, example, if A is equal to 3, B is equal to 9 and C is equal to 4. Now let's solve. Okay. So 3, A is 3 minus 9 minus 4. Solve this. So 3 minus 9 minus 4, which is equal to, so these two same simple, so 9, 10, 11, 12, 13, minus 13, so minus 13 plus 3, so the answer is minus 10. Okay, so the left hand side, so left hand side is 10, minus 10, sorry, left hand side, the we got minus 10. Now let's solve the right hand side. So right hand side, 3 minus 9 minus 4. Let's solve this. So 3 minus 9 minus will become plus 4 is equal to, so we add all the positive 4, 5, 6, 7. So 7 minus 9 which is equal to different symbols, so subtract and greater number symbol, so minus 2. So right hand side we got minus 2. So yes, left hand side is not equal to right hand side. So that is what they have explained here. Associative property A minus B minus C is not equal to A minus B minus C. Okay. Now, so here in the tabular column they have explained the same. Moving on, we will go to multiplication of integers. So for multiplication of integers, it also applies to rule. When the sign is same sign, you apply one rule, and if it's different sign, you apply a second rule. Okay, second rule. So same sign means what you do is the product of two integers with same sign is equal to the product of the numerical values with positive sign. So if same sign means, first you have to multiply the numerical value and then you have to apply positive sign if it's the same sign integers. Okay, and if it's different sign, what you have to do is, first you again same multiply the numerical value and then you apply negative sign. So to put in a tabular column, positive into positive is equal to positive, negative into plus, negative into negative will become plus. Okay, this is same sign. Plus minus different sign will become minus. Minus into plus different sign will become minus. It is this rule. Okay, so this is the tabular column. It is better if we memorize it, so it will be easy. There is plus, minus, plus, minus, minus, plus, minus. Okay, so this is what they have explained here. Here in the competition window, if you see, they have given minus 1 to the power of n is equal to 1 when n is even. What do they mean? So minus 1 to the power of an even number n, considering n is even. For example, we will take 2. Will always be, if this is even, it will always be positive. Okay. So how? Consider n is equal to 2. Okay, so minus 1 to the power of 2. Let's solve. What do they mean? Minus 1 into minus 1. So is equal to minus plus. That's what they mean. So plus 1, right? So 1. So this is always positive. Okay, so minus 1 to the power n, where n is an even number, n is an even number will always be positive. So minus 1 to the power n, where n is an odd number. Okay, n is an odd number. Let's consider 3. So what will happen? Minus 1 into minus 1 into minus 1 is equal to 1 ones are 1, 1 ones are 1. So the answer is, numerical value is 1. So minus will become, first we will do this, minus will become plus, and then plus into minus will become, here different sign, minus. So minus. So this will always be, if n is an odd number, this will always be a negative number. This is what they have explained over here. So next, division of integers. This is same as the multiplication of integers. Let's just review. Okay, so this also the same, that is division is divided into 2, that one is the same sign and second is the different sign. So if it's the same sign, what you do is we follow the rule, the same as multiplication. First, absolute value. Here it is written absolute value. Till now we were saying that numerical value, only the numerical value of the numbers. We'll take the numerical value of the numbers. We divide the numerical value and then we apply. Because it is the same sign, we assign the value of positive. So example, 36 divided by 3. 36 divided by 3. So 36. This is positive. This is also positive. 36 divided by 3, which is equal to 12. Okay, the answer is 12, positive. Because positive. The same, minus 100 divided by minus 10. What do we do? 100. Minus 100 minus 10, so it's the same sign, we will cancel it and then the answer is 10, positive. Okay, so same sign, positive, different sign, negative. Okay, so that is what he explained. If the two integers both same sign divided, the absolute value of two integers are divided and positive sign is assigned to the quotient. So rule number 2, that is if it's different, if two integers of different signs are divided, then absolute value. So here they have given the absolute value which is equal to the numerical value. We were for the previous all the steps, all the topics, we used the numerical value. So same numerical value is equal to the absolute value, only the number. Okay, then absolute value of two integers are divided and negative sign is assigned to the quotient. So different sign. So here example, minus 100 divided by 25 is equal to, so minus 100 divided by 25, because it is different symbol, you have to assign the numerical value, divide the numerical value and assign negative sign. So minus so 25 4s are 100, isn't it? So 4, so the answer is minus 4. That is what they have given here. Next, property of divisions. So here the same properties are discussed. Closure property and commutative property. So closure property, if a and b are integers, then a divided by b is not always an integer. What do they is not always an integer? For example, so what do they mean by this? So minus 28 divided by 4, okay, is equal to, is not always an integer. Okay, so here it is, the answer is
So here what do they mean by not always an integer is you might get fractions also. You might get fractions also, which is also an integers, and then you might get irregular fractions also, which is not a integer, irregular. So that's why they said it is not always an integer. You might also get regular fraction, regular numbers or irregular numbers. So that's why they have mentioned here not always an integer. Okay, so here they have explained examples. So for example here, so here 7 divided by 2, 7 divided by 2, so 7 divided by 2, so 3 2s are 6, we put 1. So what do we get is a mixed fraction. We get mixed fraction 3 1 by 2, correct? So this is a mixed fraction. Mixed fractions are not called as mixed fractions. So that's why it is not an integer. That is why closure property, if a and b are integers, then a divided by b not always an integer. Integer you can get, but not always an integer. Next, commutative property. If a and b are integers, then a divided by b is not equal to b divided by a. So commutative property does not hold in division of integers. So first let's understand a divided by a is equal to 1. Okay, when a is not equal to 0. So with an example, 5 divided by 5 is equal to 1. Okay, next rule is if an integer divided by 1, if an integer is divided by 1, the answer will be the integer. Okay, so example, 6 divided by 1. So 6 divided by 1 is always 6. Okay, that's what they have explained here. So third one is 0 divided by a is equal to 0. So for example, 0 divided by 7, what is the answer? It is always 0. Okay, and the fourth one is any number, an integer divided by 0. Any number divided by 0 is undefined. You can't, means it is not defined. Any integer divided by 0 is always undefined. So this is what they have explained over here. We have reached the last part of this video. So if you're still watching, what are you waiting for? Click the like button, share, and also subscribe. So next 2 videos, it will be the solved examples covered in this chapter, and of course the MCQs. Meet you soon in the next video. Until then, bye.